Hello everyone. Today we'll start talking about reactions of aqueous solution. First I'll be talking about precipitation reaction and I will talk about ionic equation. I will provide a link for downloading the material in the description of the video. First, aqueous solution reactions are classified into three groups. Either it's precipitation reactions or acid-base reactions or oxidation reduction reactions. For oxidation reduction, it is subdivided into combustion, displacement, disproportion, and combination. And for displacement, it is also subclassified into hydrogen displacement, metal displacement, or halogen displacement. Today I'll be talking about this part, precipitation reaction. So, for precipitation reaction, it's a common reaction that occurs in most of aqueous solution. This is a result of insoluble product. So, if I have two components that react together in aqueous solution and the result is a precipitate, this is what I call precipitation reaction. Usually, it will involve ionic compounds. Metathesis reaction itself is another name of the double displacement reaction. This is when the two reactions like AB plus CD react together to give EC plus BD. This type of reaction we call it metathesis reactions. So what tells us if there will be a precipitate or not? The solubility will tell us if will be any precipitate or not. Solubility itself is the maximum amount of solid that can dissolve in a given quantity of solvent at certain temperature. Here are the solubility rules that we should all remember when we dissolve in water at 25 degrees centigrade. Usually we have all alkali metals dissolve in water, all compounds that will contain alkali metals such as lithium, sodium, potassium, rubidium, and cesium. They all will dissolve in water. Also, if my compound contains ammonium ion, nitrate, bicarbonate, chlorate, all of those will dissolve. All halides except for silver, mercury, and lead, they will not. The three of those will not dissolve, but all other types of compounds that contains halides will dissolve in water. Sulfate are one of the soluble compounds. One of the ions that when the compound contains them, it will be soluble, except for silver again, calcium, strontium, barium, mercury, and lead. There will be some insoluble compound, some insoluble species that if my compound contains those insoluble species, they will not be dissolving at all, like carbonate to some extent, like carbonate, phosphate, chromate, sulfides, and hydroxides. Except for few things, carbonate that contains alkali metals. So if I have something like calcium carbonate, it will not dissolve. But if I have something carbonates of alkali metals such as calcium carbonate, it will be dissolving. So all alkali metals ions will be dissolving. Also ammonium ions will dissolve. All hydroxides, like we see here, doesn't dissolve in water except for alkali metals again and barium ions. Both of them, if they are they are forming hydroxides, they will be dissolving. Now looking at another example, if I want to know if ammonium sulfate will react with sodium hydroxide or not, and if there will be any precipitate or not. First I need to balance my chemical equation. So I have here two species of aluminum and three species of sulfate, and here sodium hydroxide, one species sodium and one species hydroxide. So to be able to balance this chemical equation, I have to multiply sodium hydroxide by 6. The result of this reaction, the metathesis reaction, says that sodium will be sodium sulfate and aluminum will be aluminum hydroxide. So I will have aluminum hydroxide plus I have 2 aluminum hydroxide plus sodium sulfate, and I will have 3 sodium sulfate. Now I balance my chemical equation. If I try to write down my my ionic equation, I have to write 2 aluminum with valency 3 and sulfate SO4, and I have 3 species here, plus sodium. I have to remember also all hydroxides are not soluble except for sodium, alkali metals. So sodium have 6 species plus hydroxide, which I have 6 species as well. The result for this one will be sodium sulfate. From here I could see that all sulfate are soluble and all alkali metals usually soluble, so I will have also Na6 Na plus SO4 on that side. But if I looked here at aluminum hydroxide, so all hydroxide are insoluble except for alkali metals, and aluminum is not an alkali metal. This is why aluminum will be aluminum hydroxide. In that case it will be apercipitate. Now if I cancelled my ionic, I cancelled the 2 parts that appeared on my on the 2 sides of my ionic equation. It will be the sulfate and the sodium hydroxide, and if I try to write the net ionic equation, it will be 2 aluminum plus 6 hydroxides to give me 2 aluminum OH by 3, and that will be apercipitate. So this is my net ionic equation, and for that this reaction will happen. So what is the molecular equation and what is ionic equation itself? If I looked here at the reaction of lead nitrate with potassium iodide to give me lead iodide and potassium nitrate, this reaction I name it molecular reaction. Why I name it molecular reaction? Because all what is presented here are compounds. But if I try to write down the ions, or the species that forms ions in the water, I will start writing the ionic equation. Let's try to write the ionic equation for this molecular equation. So my lead will be lead ions, will be presented as lead ions because lead nitrate are soluble, plus I have 2 species of nitrate, and all alkali metals are soluble, so I will write my alkali metals are soluble and the halides are soluble species. The result will be, let's start with this one. So I have 2 potassium ions and 2 nitrate ions. For lead it's solid, so, and I know that from the previous table that lead iodide is actually insoluble. So if I looked here at this one, so all halides are soluble except for lead and of course mercury and silver. So this will not be soluble, so I will write it as EbI2 solid. So if I cancelled each part, this equation, first I need to name this one. So this is my ionic equation. Now I need to write my net ionic equation. So I cancel this one with this one, and that part with that part, I end up by my net equation. So I will have lead plus 2 iodide ions to give me lead iodide, which is apercipitate. This is my net ionic equation. So I first have my molecular equation, then ionic equation, and the last one, which after cancelling the represented species, it will be my net ionic equation. So step for any writing any ionic or net ionic equation, first I need to balance my chemical equation. Second, I need to write my ionic equation keeping solid formula. So I have just to write the dissociated species in water, but I keep my solid formula as it is. I will start to cancel the spectator ions and write a net ionic equation. Those ions, so if here I looked at this one and this one, we name them spectator ions. So I cancel spectator ions and keep the rest of the ions. This will be my net ionic equation. Then I have to check my charges and the number of atoms if it is balanced, my net ionic equation is balanced or not. So in here I could see that I have 1 lead and 2 iodide, and I ended by 1 lead and 2 iodide ions. Now let's take an example to predict what happens when a potassium phosphate solution is mixed with calcium nitrate solution. So I have to write my net ionic equation, but first I need to look at if my equation is balanced or not. So first step, I have to balance my chemical equation. So I could see here that it is already balanced chemical equation. I have here 6 potassium, and the number of nitrates are equal on both sides, calcium and phosphate. Now let's write the ionic equation. So my ionic equation, anything that will contain alkali metals will be presented as ions. So I have 6 potassium plus 2 phosphate ions plus this part will be soluble as well. So from here I could see that all nitrates are soluble. There is no exception to that rule. So I will write calcium ions plus nitrate ions. I have here 6 nitrate ions to give me. So if I looked here, I could see that sodium phosphate, so all phosphate from this one, I could see that they are not soluble, so this one will remain as it is. So plus anything that has alkali metals will be soluble, plus. Now I have to cancel my spectator ions, nitrate on both sides, potassium on both sides. Now I end up by writing my net ionic equation. 2BO4. Have to remember to write the right numbers of the balanced chemical equation, and calcium to give me calcium phosphate, which is a precipitate. And my next video will be the acid-base reaction in aqueous solution. Thank you and goodbye.